Businesses, libraries, dentists, doctors, everyone keeps records. Now, as this picture shows, okay, if your surname begins with K and L, you've got a good chance of being found on that middle trolley. But to find something in a hurry is going to be a problem. All these folders could contain information, and if we want to find one straight away, where do you even start? This is where databases come in. So what is a database? A database is a method of storing data in an organised form. And that's the key part. Data in an organised form or an organised structure. The key word is organised. So if you put in an exam, it's a way of storing data. Well, it is, but it has to be in an organised form. You need that keyword organised. The advantage of a database is that the data is quick and easy to sort through and search. Databases store data in tables. So where a database is used? Websites like eBay and AutoTrader, on the back end of those is a database. So when you do a search, you are basically conducting a query, and we'll look at that later on, and we're looking through the database for a specific record. So let's take some data. First of all, we need to put it in a table. So a two-dimensional structure is used to store data. That's what a table is. So these columns, song and artist, is our two-dimensional structure. Each row is called a record, and each column is called a field. So in this example, song is a field, artist is a field, and each row is a record. Which is fine for storing information, but we've got a bit of a problem, as this one shows. Let's say that Ryan Adams does a cover of Oasis' Wonderwall. In the field, the song is called Wonderwall for both records. So how do I uniquely find which one I want? How do I know whether I want the Oasis version of it or the Ryan Adams version of the song Wonderwall? What we have to do is put an identifier that uniquely identifies each record. This is called a primary key. So now we've added a field called ID, and the ID number is unique for each record. So Oasis have a different number to Ryan Adams. The primary key is a unique identifier for each record. There can only be one primary key per database table. Think of it like a car registration. You haven't got two car plates of different numbers on them. Each number plate belongs to each car. We can keep adding data into our table, and it would it'd get really big. This is called a flat file database, where all the data is in one table. It's called a flat file database. So looking at iTunes, this would be an example. This is a massive file. If this was a table, we'd have all our music with different fields, name, artist, time, just in one place. Because those files get too big, a relational database is preferred. So in this example, users is a table, tweets is a table, and following is a table. And the information and the fields in users comes from the tweets and the following table. Let's try and explain that again. So let's say in a flat file database, I've got member ID, first name, last name, gym address, personal trainer. As we can see, Utoxeter is spelt with an uppercase and a lowercase. So in theory, they could be two different places. I haven't put any information for personal trainer, and it's not easy to work out which record is unique. Okay, we've got a primary key for a member ID, but what if the name of the gym changes, or the address changes, or my name changes? The data needs to be in different tables. So this is the problem of having it in a flat file database where all the information is stored in one table. What is more efficient is if a table only contains the data about itself. So trainer ID. Trainer ID's got a primary key, it's got the name of the trainer and their last name. Gym information. Each gym has its own gym ID for the primary key, an address and a telephone number. Each member has their own primary key, the first name and the last name. And then we construct a table about that information. So member ID comes from the member table. Gym ID comes from the gym table. Trainer ID comes from the trainer table. First name and last name come from the member table. So now, if someone's name changes in the member table, it will auto-update in our main table at the bottom. If Utoxeter is spelt wrong on the gym ID, it doesn't matter because it updates onto the main table. So the idea of a relational database is you create a relation with different tables. So our bottom table is a relation made up of relationships with the member table, the trainer ID, and the gym ID. And it's so data isn't redundant. Basically, if you write the same data twice somewhere, there's a chance of an error being made. Whereas if that data only exists in one location, when you change that one location, everything will get updated. Now at GCSE, we know about primary keys, but there's something called a foreign key as well. And what this table is missing is the primary key for this table. So this time, it's working properly now. Order ID, because this bottom table is, let's say it's an order. So order ID is used to identify each of the records within that table. Member ID is a primary key in the membership table. Gym ID is the primary key in the gym table. And the trainer ID is the primary key in the trainer table. When a primary key from one table appears in another, it's known as a foreign key. So a primary key, as we said at the start of this, each table only has one primary key. And in this example, it's order ID. That will uniquely recognize each record in that table. Because gym ID is a primary key in the gym table, it's known as a foreign key in another table. So all you need to know is a primary key identifies each record uniquely. A foreign key is a primary key in another table.